Oh, okay, we are on the bottom. And Bruce, I'm afraid this is not that sedimenty.
I have the bottom of my sonar, agrees with the altimeter.
Well, we'll still be hopeful or not hopeful, depending on what you think works best. And Chris, I just want to remark that you said earlier, all joking aside, so I think you should put a quarter into the OER budget every time you make a joke today.
That was all joking aside for maybe an hour or so. And then anything goes after that.
Coming down, reduced delta.
Okay, that was just a joke. So
I know. But my problem is that that could use up that could impact our cash flow at home if I was to put a quarter in every time. So no, it's not going to happen. We've got something in the distance already. A couple of sponges, I think, or corals. Wow, I think they're corals. So our bottom is 1,595 meters.
ROV nav bridge.
We don't have a name for the seamount. It's never been named. I call it New Seamount 6.
Let's set bail for due south for now.
I don't know what else to say about it.
Yep, thanks.
Alright, so we'll start with 25. Well, Seamount 6 has a certain ring to it.
Yeah.
Okay, try that for the Z-bias, and I'm going to start coming down, Dave. I'm going to back toward you a bit and come down to the bottom.
Okay, I'm at a delta of about 13.
Okay.
Tether looks good. It's well off to starboard.
well, it looks like you landed in a good place to try to find a rock to collect.
Okay, Dave, you can go ahead and adjust
Yeah,
some arms here.
Oh, look at that.
Okay.
There's a crinoid.
There's a couple of stock things here.
Yeah, I'm trying to get sea scribes set up. I'm a little late getting on this morning, but
And a fish.
there's a fish.
Bob sees a fish. Oh, there he is. You can go for zoom.
Can't the fire rush shrimp?
Nope. Nope.
But there's
Oh, there he is. Okay.
He's not going to cooperate,
Yeah,
though.
he's bugging out fast.
Okay, we'll go full wide. Thank you, video.
All right, Bruce, this is going to test your skill when you see that fish.
You know, I haven't been able to find where it is on the screen.
It's because I think it probably came and went.
All right, do you want to take a look at this, Chris? Or?
Yeah, sure, please.
Okay. All right.
Okay.
We're still getting set up, but this will give us some time.
Did you get a sense of what it was?
It was very black, and it could have been that black macrurid that we've sort of been seeing flitting here and there the last few dives.
Okay, well, maybe we'll see more here. Even though it's not highly sedimented, it's promising, so cross our fingers.
So it looks like we have a stalked crinoid. This is an echinoderm. These are relatives of sea stars and sea urchins. This is the stalked variety, if you will, of animals called crinoids. We've also seen crinoids as what we call feather stars. You can sort of see a resemblance in that there's a cup with lots of arms protruding from it, and then those arms in turn have structures that project off of them. These are filter feeders. They pick out food from the water. This particular form of crinoid is a stalked crinoid, and these don't move as opposed to feather stars, which can actually swim. These are this body form is very old, and you can find fossils of these animals as far back as the Paleozoic. There are lots of fossils in the Midwest that many people will probably recognize on road cuts on the side. and those
Let me come out a little
are
bit.
the skeletal elements that make up the stalks of these animals.
That's good.
Sometimes those little fossils are called Indian beads, and they're essentially the sort of tic-tac like, or not the tic-tac, lifesaver shaped components that make up the long stalk. You can sort of see that the stalk is made up of cylindrical elements, and there's a round circle in the middle of them. So that's what you're actually seeing as fossils, and the stalks are made up of them all the way down to the bottom. Some of these can move. Some of them are planted and can't move. They're what's called sessile. Occasionally we see parasites on them.
I see a fish. Let's zoom out.
Let's go see some fish.
There he is.
Oh, yeah. Okay, Bruce.
All lights are deployed.
Oh, come on. But I know what he is, and I'll bet Bruce at least can go to family.
Now, this is the same type of fish that we saw at a distance early in the dive yesterday. It's a halosaur, deep-sea spiny eel. They're relatives of the true eels, but they have a separate dorsal fin on the back and fins on the belly. We didn't get a good look at it, but it looked like an Aldrovandia, and it was very pale with a long snout, so it resembles something that we saw in the Mariana Islands that Ken Sulak in Florida had suggested could be Aldrovandia rostrata. There is another species recorded in the Hawaiian Islands called Aldrovandia affinis, and that might be a possibility too. It's not the species of halosaur that we see most often, which are dark brown in color. That's Aldrovandia polacra. So I tossed out a bunch of names, but it's either Aldrovandia
yeah, you guys ready for a move?
or Aldrovandia
All right,
affinis.
range 30 meters, bearing
Thank you, Bruce.
020 degrees,
And that was
speed
the
decimal
voice
2.
of Bruce Mundy, who's a premier fish biologist for NOAA's Inouye Regional Center on Ford Island in Honolulu. And he's also operating the Ford Island Exploration Command Center, ECC. We've got two of those in Hawaii. We have another one at the University of Hawaii. And Les Watling has been opening that up. I'm usually there in that one, but of course I'm here, so Les has been going in there as much as he can and opening that up for some of the UH faculty. So, did we do introductions? We didn't do anything. We didn't say where we are or what we're doing or anything. So this is a live broadcast.
ROV bridge move initiated.
Yep, sure.
Move initiated. Thanks, Rich.
Yes. Did you guys see that coral when you landed? It's unclear to me now exactly how you've moved since we've landed.
But
If
to follow
you looked up and in the distance, and I just want to be sure if you're not going that way, we can at least do a zoom.
Come back.
Did you copy that pilot?
I think it was one of the tall tridents.
It should be okay.
Yeah, we'll see if we can reacquire that, Bruce. Scott, sorry.
I did not see what Scott was
Yeah, I
talking
don't
about.
know. It wasn't backwards. It was in the distance. It was forward.
Yeah,
So it's just unclear to me how you turned since you settled down.
Yeah, we put in a ship move. Here's our crinoid, but we can't get out too far yet. But we'll be making our way upslope shortly.
Sure. Well, Scott, if we see it again, we'll certainly stop and.
Look on the horizon, so to speak.
I think he's suggesting if you want to take a quick peek by panning up, you might spot it.
We'll take a quick peek. I don't like to look out too far because we look at places we can't go to yet. But we'll be there soon. We'll take a look up there.
So there it is, right there. It's right at the edge, but let's see if we can first get set up and whether it's possible. So you're seeing a live broadcast from the NOAA ship Okeanos Explorer, and we are in the Johnston Atoll unit of the Pacific Remote Islands Marine National Monument.
I think that's
This is
what
a
you
wonderful
want.
U.S. resource that's protecting a lot of amazing marine life around atolls and islands that are
south sound good to you, pilots?
within U.S. territories, and these include
Great.
Wake Island, Jarvis
We'll keep
Island, Palmyra, Kingman, Howland and Baker, and Johnston. And So it's a really marvelous resource. A lot of the shallow water and land creatures that are on these islands are reasonably well described, but the deep water animals are virtually unknown, and that's why we're here. We're trying to help out the monument and find what they've got in deep water. I'm Chris Kelly from the University of Hawaii, School of Ocean and Earth Science Technology, and you are?
And this is Chris Ma from the Smithsonian's National Museum of Natural History. We are serving a relatively, for deep sea areas, a shallow area, roughly 1,600 meters, but we're already seeing quite a bit of interesting life here. And
on the fly.
We'll be traveling up a sort of a cone on this freshly discovered and mapped seamount, which we only just mapped
another fish
this morning.
Yeah, you can zoom fish.
This is a different fish. Good eye.
So we can move Jordan here.
All right, Bruce, I think this is going to be an easy one.
Yeah, this is a grenadier. They're also called rat tails. This is a large individual. This is in the genus Coryphaenoides for sure. It doesn't look like the Coryphaenoides longiphyllus that we see. My guess is that this could be Coryphaenoides armatus. I don't know, Chris, if you have thoughts about that. But Coryphaenoides armatus is a species that's distributed worldwide. It's a large predator and scavenger. Chris, do you have thoughts about the species identification? An excellent video, by the way. That's just perfect, getting the whole view of the animal like that. It's wonderful. Chris, do you have thoughts?
Yeah, so Bruce, I was thinking that Coryphaenoides armatus is a bit deeper than this. We're sort of on the shallow end of our dives out here. We're at 1,600 meters. I always thought Coryphaenoides armatus was almost abyssal, down 4,000, but I'm not sure. You would know better about that.
Oh, wow. Is that... You hadn't made any changes yet, Levi? And it started doing that?
So there is a possibility that this is Coryphaenoides longiphyllus, which is a species found in the Central Pacific at these depths. We saw them in the 2015 dives. This one looks a little lighter in color, and it seems like the pelvic fins of the whisker on the chin aren't as long as that. I'll have to look up the depth distribution of armatus to see, but we definitely have the genus on this. These are more active animals than some of the fish that we see in deeper waters. It's undulating its tail, not swimming extremely actively, but they do come to baited traps and to falls of large carcasses from the sea surface from shallow water. They're scavengers as well as predators.
Great. Thank you very much, Bruce.
So now
is this a good time to introduce the front row, Dan, or would you prefer a little bit later?
Yeah, we can do it now. So I'm Dan Rogers as pilot right now. We've got Levi Unima on nav, Dave Casagrande on co-pilot, Bob Knott in video, and Tara Smithy doing our highlight clipping, and we're all with the Global Foundation for Ocean Exploration.
Thank you very much, and we didn't give Matt a chance to introduce himself, who's sitting left to me.
Am I on there? Hey, this is Matt Dornbeck. Can you hear me? Oh, the settings.
There we go. You got it.
Hey, this is Matt Dornbeck, part of the NOAA Center for National Centers for Environmental Information, and also part of NOAA's Deep Sea Coral Program. So I'm out here annotating and helping lead scientists with their sample collections and everything like that.
It's 19 to max.
You got another one, Bruce, and I think this is... All right, I'll let you give your call on this one.
Well, it was another halosaur. It looked like it's darker in color, and we can't see the top of the head, which we really need to see to get... Oh, here we go. We're zooming in. The genus Aldrovandia lacks scales on the top of the head, over the eyes, and down toward the snout. I'm not seeing an indication of those. And this is darker than the previous one, so this could be Aldrovandia phylacra. the most common species of halosaur that we see on these dives. Again, Chris, I'm always open to other suggestions or corrections.
Sounds good to me.
Hey, Dan.
Yeah.
There was a small kind of
Zoom
sedimentary
out.
structure in a sediment pool to the left.
Zoom out. Thanks.
There's two of them, and I think it was in the small. It was in the one on the left. There's two of them, and there's a right one and a left one, and I think it was the small.
Is it in view right now?
Yeah.
Can you tell me what part of the screen?
Center, I believe.
Center.
Right in the center. Let's get lasers on.
Lower center.
Oh, I see.
Yeah, that's it. You see, it looks like a little.
Potential starfish.
Actually, believe it or not, I think I know what this one is. I just
Okay.
like to talk about these other things other than starfish because these are so weird.
No problem. Let's go ahead and zoom in.
Oh, actually, a little bit up to the right.
To the right. Oh, in the sediment there.
Yeah.
How did you spot that?
Oh, I'm obsessive about these things. It's in these. Sometimes it's funny how I cut these things out. So this is a sedimentary structure made by a single-celled organism. This is from a foraminiferan, probably in the group Xenophilophoria. These are
a while ago, right?
literally giant amoebas that live on the deep sea floor, and I really just enjoy talking about them because they're so weird. But they can create sort of reticular networks that they're usually just sort of detrital feeders. They just sort of eat whatever organic goo comes to them. But some of them are predatory, and some of them can actually devour animals. So, but we'll see a lot of these funny little sedimentary structures and probably little tree-like things. And a lot of times we forget that animals aren't the only things that live on the deep sea floor.
Oops.
So are we going to
right there in the
continue
left. See, that's on
to
max.
keep
Okay.
Scott at bay with
see
that
that,
big
Chris?
coral in
Oh.
the background?
Yeah.
Maybe. There's just one. Is that a sea star?
I can't tell.
don't
Let's
know
zoom
what
out
that
and get a
is.
little closer.
Yeah, we could take a quick look, and then we can go look at the coral because I'm sure Scott will be.
Yeah, and we should have
Chomping at the
tether
bit.
now to get over there.
Yeah.
Let's take a quick look at this.
I'm just glad to know you're heading there. It wasn't clear to me where we were going.
Yeah, I'm sorry, Scott. Don't worry. I just sometimes I like to get these funny little things out of the way before we forget them.
Yeah.
Oh, absolutely. Go for
You should see him on the beach. He's always
You wanna
taking
do a
his
stat
hands
zoom?
and digging
Or
around in the sand.
Not sitting down for.
So am I.
Is that a little
little-
holothurian, maybe?
No,
What
it's
is
a
that?
shell. Probably
Yeah, I
a
think it's
shell.
probably a pteropod. shell.
Pteropod,
Okay.
yeah.
Yeah. Okay. Well, we can
zoom out.
move on. There's like I said, there's a big coral I think in the back
up there?
Yeah, that's it. Thank you.
Oh,
And a star.
And a star.
Oh.
Where's the starfish?
He's a big guy right
Oh.
there. On the,
right.
Oh my.
Oh.
which one are we
yeah.
looking at first?
Let's go to the coral first.
Well, which direction? What makes sense to go to first?
It doesn't matter to me.
Oh,
They're both
okay. Well,
close to each other.
let's go to the coral and
Okay.
then the star after
Hey,
that.
I'm patient.
You're going to be on the edge of the fan.
Go to the coral before the star eats it.
Exactly.
It depends on which star, actually.
Or
So,
go to the star, it moves a
I'm not
little
sure that's one of
faster.
the coral-eating ones.
Yeah, it looked like one of the ones that picks on my sponges.
It looks like we're going to the coral first, and this is what I thought it was from a distance. This is a bamboo coral, and it's got a very distinctive morphology. So for a change, this is one of the ones that's
For
easy
tethering,
to
we'll
recognize and that we can pretty confidently
Here it's
say what it
030
is.
anyway.
The interesting thing is that it is an undescribed species as yet, and with any luck, Les Watling and I will have a paper out this year giving it a name finally. We believe that it is a genus
Yeah, I'm right over the top.
separate from all the other bamboo corals. And one of the things that really distinguishes it, you can see that it's kind of growing as a candelabra atop a very long
That's actually pretty tall.
stem. But at that first
bit more
point where
height,
it branches, it forms a little trident. And when you see this early enough in the growth series, when it's younger, it only looks like a trident sticking out from the bottom. Then as it grows, it continues to sort of add branches going outward from that initial trident. This branches at the nodes,
Okay,
and
can zoom in.
for Annotation, Chris, we would say that it's in clade I4.
And I already got it in the annotation. I have it up on the Okeanos Animal Guide imagery. So thank you very much, Scott. This is a beautiful bamboo coral with this beautiful lyrate form. It's very distinctive.
And that's an undescribed genus, you say?
That is correct, yeah. One we're working on now. It is less than I said. It was our next paper to go, so let's see if we can actually get that done this summer.
Woohoo!
I'll note that the first time we ever saw this was on an ocean exploration funded cruise to the New England seamouse. So as near as we can tell, based on the morphology and the genetics, this seems to be the same species in both oceans. So it has very wide geographic distribution.
Wow.
Yeah, there's another kind of fun fact about this bamboo, Scott, also. I'm trying to remember Les's name for it, but I collected one of these in 2007 up in the northwest Hawaiian Islands, and Les was telling me that it's got a hollow core in these branches. They used to call them, he was calling them the straw or something like this. Does that sound familiar?
Slurpee.
Slurp, yeah. That's right, Slurpee.
Yeah,
Slurp.
so there are several bamboo corals where that white skeleton you're seeing through the tissue made of calcium carbonate is actually hollow like a soda straw. And in different species, it's either quite wide, that opening on the inside, or it's very, very small or solid. So there's a range of variation there. We don't quite yet know or understand how that is related in an evolutionary or taxonomic or systematic perspective.
Great. Thank you very much, Scott. So
okay, let's go out video.
And now, onto the starfish. Excellent.
Oh, I see another big stock off on the left here. I'll just take a peek over there.
oh, it's a different one. Wait,
We'll get there. Oh,
should we skip the star and go to the coral?
I don't think so.
Oh, maybe not. Okay. Sorry.
You, Dr. Kelly, are asking for a whooping.
That's nice. I'll just note that that's another family. Folks, whip.
yeah, quite a bit of current here.
Yeah, I'm seeing it.
It's going.
Well, this is interesting.
Kind of coming off the forward port.
Forward port. Which way? Let's see what you're facing right now. 222.
That's out of the west, roughly.
So out of the west.
Roughly, yeah.
Okay.
Roughly west to east.
Oh. Huh.
All right, I think we got the lasers. You can kill it.
Okay. Lasers off.
Oops. All right, video, you can go in.
It's making me tingly. It's my old friend.
It is. I think I even know what this one is.
Yeah, so this is one of the... At one point, this was thought to be one of the rarest sea stars known until we started seeing them all over the deep sea. This is called Pythonaster. This is in the family Mixasteridae. They're simply bizarre. We often see them present in these kinds of habitats on hard-bottom basaltish type things, and often they're sort of perched on vertical rock faces. These are related to slime stars, although I've never actually seen one actually produce slime, but they have this bizarre surface texture which is kind of filled with all of these big pillows. I don't know what they're used for. We've seen these feeding on sponges before, which is the kind of thing that I love because they eat all of Chris's stuff. But other than that, they're really kind of poorly known. They're a mystery. There are sea stars from the Jurassic that that are vaguely similar to these. So there's a lot of just bizarre things about them. We're looking at the arm tip, and those are all of the tube feet that are emanating from the tip, and those are usually used to help sense where the animal is moving and where it's going. But you can see the surface texture of this animal. It's very dissimilar from any of the other sea stars we've seen. Most of those tend to be sort of plates arranged in a pavement or some kind of skeletal net. These actually have all of these just sort of bizarre puffy ridges. That's all really I can. And then there's what's called an osculum, which is kind of an opening that opens the top of the disc into the body. So very strange kind of animal.
Well beyond you.
But we can move on. It's good to know that it's here.
I think it's okay, Dave. We've been settled out for a while.
Follow them tight.
We were, then I moved another couple meters. But, I think it's all right.
Sonar looks all right.
Yeah, I'll push out.
I'm going to go up high pack here. There we go.
So now we're coming up on, I think it's a different species of bamboo. What do you think, Scott?
Did the threshold.
Yeah, I don't think maybe you guys were laughing about something before. I had mentioned when we were pulling away to see that sea star that this is the sparse branching bamboo that we've seen a number of times. We saw this very frequently in the 2015 Papahanao
Yeah, I'm not sure,
cruise.
Levi.
And at that time, I thought they were aberrant whips, unbranched bamboo coral whips that had
We'll have to do more additional
one
research.
or two branches that may have been settling larvae, but we've seen it so much now.
I did it twice in a row.
With
Yeah, I
even
did it
more
twice in a row.
branches than this, that what I think happened
The noise
is they
test.
grow for a very
So it
long
did-
time unbranched,
At least
and
the
then we'll
noise test
put out
wasn't
a
like
branch.
drastically
You can see
different,
the big
a minute
distance
later, right? It was, so makes you
between
feel a little
these
better about
branches.
that measurement, I guess.
And
But
I believe that the branching occurs after it's actually gotten quite tall, so not when it gets to that nodal point.
I don't know.
Anyway, earlier on
It's
this
about
cruise,
diagnostic,
we
but
saw
I don't know
a
about
colony. It was kind of like
Yeah,
a
I
very
heard
sparsely branching
Lucas
bush,
talking about it.
which I predicted
I'm not
would
sure.
be one of
And your
these
Josh
much
talking
older,
about it.
so I'll be
I'm
very
not sure
interested to see
how to do it.
if that's the case. Although, I'm not 100% certain we
It
actually
just
have a
rates the
sample
settings to
of the obvious
text
sparse
file or
branch. I'm going
something.
to have to go back and see if we got one of those in 2016. So it is bamboo coral. As we said several times in these dives, we have a look at the distribution of the sclerites, the microskeletal elements made of calcium carbonate that are embedded in the tissue, and we look at to see where the branch points are. And this branch might be curling out towards us, so I can't tell if it's coming from a node or an internode. I suspect an internode.
You can zoom out a bit, video.
It's a bit hard for me to see, and then we're seeing living on it is a very large
Hold there.
with its pedal disc kind of wrapped around the branch of the coral, and so it's probably killed off or digested some of the polyps that are underneath there.
Okay, are we good with this,
All right,
Chris?
we're good.
Okay,
Thank you.
let's zoom out. And I'll come to starboard, co-pilot.
Okay.
So a couple things I'm
I'm gonna follow
really
you back
happy
to
about so
starboard.
far is we've seen a bunch of animals, fish, and corals
transceiver
and
threshold
sea
and there's
stars.
transponder
Plus we've
threshold.
got a
Oh,
current.
okay.
Which one's which?
Well, it looks like
Well,
Sirius has been tracking all right, right?
So all good
That's
signs.
correct. I was changing transceiver.
Unless the
Sometimes
unless the
it's Sirius.
transponder one is just for the acoustic trigger or something.
And as just a matter
Which
of
we're not
novelty,
using on D2
we've
right
seen
now.
things from not just
That's true. I
several
think you're
phyla, but
correct.
several kingdoms.
220.
That's true.
2 kingdoms.
Thanks, video.
Something in suspension right side.
I see it there. We can go for
So
it.
do you think this substrate is mostly broken up manganese
there.
crust, or are these rocks that they have basalt inside?
Oh,
What the
Yeah,
heck is that?
Bruce.
that's
Sea
a
spider.
munopsid isopod, little swimming crustacean, doing the backstroke.
So
Go ahead.
Sorry.
Sorry.
Go tighter.
yeah, to answer your question, Bruce,
Hold there.
I suspect they probably do have basalt inside of them, but because it's so flat, they could also be just solid manganese crust. So I was going to wait until we got in onto the cone itself, and then find some area with pillow lavas. And
Okay.
what is
let 'em
that? It's just an ophiuroid?
Could we see that? I think it's a brittle star, but there's nothing. It's interesting. I don't know if it's. It looks like one of the ones that lives on coral, but there's no coral here. Or maybe it's an Oh, it's a brisingid.
Is it?
Yeah. Let's. I think
Oh,
that's what
yeah,
it is.
sure.
There's a little one under the rock too. You want to zoom in?
Yeah.
Hold on.
Yeah, funny way it's curling its arms, isn't it?
No, it's a strange angle.
Is that a brittle star?
Oh, is it? Oh, wait. Maybe it is a brittle star. I'm sorry. Oh, no. I've mistaken a brittle star for a brisingid. My life is over.
Boy, are you going to hear about it on Twitter this evening?
Yeah, I know. But look at those finds. Those are really different. That's an interesting brittle star. I don't know that I've ever seen one quite. I don't know. It might be an Ophiocanthed. I'd need to see the disc. Usually, Ophiocanthids live on corals or sponges. I don't see them that often, at least during our dives, free living like this. But they certainly can be free living, so it's hard to say without getting more details off the surface.
Pretty serious spines on his arms.
Okay. Well,
Yeah.
let me come around and see if I can get the disc for you real quick. And then
Thank you.
we'll
Much
take
obliged.
off.
And we got the other one in the background.
Yeah, you got the little one under the rock under there. You see
Yeah,
that?
that one actually might be a separate species as well, the one under the rock.
It's kind of on the back side of the rock. I'll do my best here.
Do you want more lens?
This is good.
Ah, okay, yeah. So it isn't it's definitely an Ophiocanthed. It's one with much sharper
Okay,
spines.
zoom in real quick. Snap zoom.
Than
Hold there.
think. And it looks vaguely. It's a little different from the other ones. It might. Yeah.
All right, let's zoom
Yeah.
out.
I'm not sure if that's a separate genus, I think, from the other ones that I've seen. But there are
Something
places in the
Yeah,
South Pacific where
over there.
there are Ophiocanthids that literally cover rocks because they've
Now, if we're reading about
climbed
one
on
meg on the
to
DC
the
bus
surface
return,
and they're
can you,
suspension feeding.
If you have a minute,
But
watch the D2CTD.
obviously, we don't see that here, at least not yet.
There's a fish upper center.
See it there.
Tend to prioritize fish often on these
Pretty noisy
dives
down
because
there.
we certainly don't see that many. So when we see one,
Range
we
from
actually want to get a look at it.
2 to 2.4
Really?
on that unit of
Hey,
millimeters.
Al. Well, thank you. The fish also come up and swim away, so they're you kind of
It all
get pictures
plots on
of them
top
when
of
you
itself
can.
right now, right?
because
So
they
I can
move.
watch.
This is another one of the dark halosaurs.
Yeah,
It would be good to see if we can get a close-up of the head, but I know it's far away. My
zoom in.
guess is it's another Aldrovandia
Hold there.
polacra, one of the halosaurs. These are infaunal feeders, or epibenthic invertebrate feeders. They feed on
by
polychaetes
0.1
and
and
small
0.2 probably.
crustaceans. They probably love something like one of
Oh,
those
there's
small
a big jump.
individual, one of those isopods that we just saw.
Very
This one's not going to be cooperative. It's not going to show us the top of its head. Anyway, these are distinguished also somewhat by the large scales along the lower part of the body that
All right,
contain
let's
lateral
turn off
line
the screen.
sensors,
Let's
and
map
you can
it
see
in.
the large pores and cavities
Yeah.
on the head
Big
that
jumps over here
contain
on that
vibration sensing organs. So they're probably relying much more on sense of vibration and movement in the water to find their
all
prey and
very
also to detect predators than they are vision, even though they have large eyes. Of course, there's no sunlight at these depths.
Yeah, you can come down
So
a couple
it's nice to
little
be
bit,
in
yeah,
this
for
lower
sure.
gradient habitat with some sediment that has food for fish like this. When we get up into the higher gradient
do a snap
spikes
zoom.
of the seamounts and on the ridges, we'll probably see less of these.
Hold there.
So my guess is a halosaur, probably Aldrovandia polacra.
Yeah, thank you, Bruce.
Dan, you read my mind.
Yeah, I figured.
So this is a sea cucumber. These are the deep sea versions of the shallow water ones some of you may be familiar with that live in tide pools and tropical coral reefs. But deep sea cucumbers are a slightly different kettle of fish. They have in this particular case, I believe this is the family Synallactidae. Would you say that's the case, Chris?
I am looking it up right now.
But
it's got a lot of tiny little tube feet, so I'm wondering whether it could be late Magonidae.
Yes,
Okay.
but these are also possessed of a translucent body wall, and you can see the gut right through it. They're essentially deposit feeders. They absorb all the sediment, eating the ooze and the good organic stuff that comes down from the ocean floor, and they digest that and then poop out the sort of cleaned sediments onto the ocean floor afterwards. And this actually is an important ecological component because they can change the microbial fauna. They can sort of deconsolidate and sort of clarify the sediments for other animals that burrow through the sand and whatnot. So important animals, although very unusual looking.
So you folks are going to need to stand by for a moment. We're having a front row change out at the moment, that time of the morning. And so we're going to be just sort of drifting very slightly while people change seats, and we'll be back looking at animals in just a minute.
While we're drifting here, Chris, I will share with you, I was just looking in my database, at least for the trident type or candelabra type bamboo corals that we were just imaging earlier, at least for the ones that we have sampled, they are all shallower than about 1,850 meters depth. So that's kind of interesting. That's consistent with the depth that we are at today, and it may suggest that that particular species doesn't get much deeper, which is why maybe we haven't been seeing it.
It's a good point, Scott, because as you pointed out, we do a lot of dives that are over 2,000 meters.
One of the important aspects of zonation, or of the distribution of animals in the deep sea, most people think of them as sort of shallow water species as being distributed to certain areas. So perhaps the fauna from New England is different from the fauna in the southwest part of the United States. But in the deep sea, a lot of the animal species can actually vary by depth. So different depth zones have different types of species and different types of different types of faunas of animals. And so you'll often see a changeover from the deep sea, quote unquote, the deep sea faunas.
Excuse me, pilot. There's a big fish in the background. Can you see him, please? To the upper left corner. He's going off screen.
I'll get him. And stand by.
Sorry for the interruption, but fish are quick targets.
No worries. Off to the fish.
As we find the fish, I'll just say, Chris, to finish that comment, totally agree, and it's one of the values of these Okeanos exploration cruises, Okeanos exploration cruises, is it gives us an opportunity to see lots of different depths in lots of different places, and either get surprised by distributions that we were not expecting to see because of depth or something else, or to confirm that, yes, indeed, these are restricted to some particular depth zone or geographic area.
I have not the tether to pursue.
Attention all hands.
So even though we can't see this really well, just from the shape of the tail, shape of the body, the rapid swimming, and the large size, this is a cutthroat eel in the genus Anaphobranchus. I'm not sure that we can say more about it because it's not letting us get close enough to see the position of the dorsal fin. This is one of the larger, more active predators down here in the deep sea. These things have very sharp, large teeth in the jaws. Likely, they do feed on small crustaceans and probably even small fishes, and so it's one of the top predators in this habitat. So it's a cutthroat eel in the genus Anaphobranchus.
Thank you, Bruce. That one had some girth to him. That was pretty interesting. I was not expecting it just to be one of those eels. I thought we were going to see an ophidiid or a cusk eel or something like that.
It did have a very cusky
selected spring is 010. We went past a juvenile Metallogorgia, the one that kind of looks like the groomed poodle.
Alright, I'm around 010.
Well,
tossed around a little bit, but we probably put in 30 meters in that direction.
Copy.
Okay, we maybe it looks like we are kind of on the very base of the slope of this volcanic cone that we've targeted for most of the dive today.
Bit surprised there aren't sediments here, or more sediments here, Chris.
Yeah, I know. Sometimes you get fooled in some of these flat
30
top
meters,
geos,
010
which
coming
are
up.
flat top seamounts. They can have a very hard layer on top rather than a
Go
deep,
ahead now.
sort of a deep layer of sediment, which so they alternate. We've seen kind of both over the years. If we could take a look at this,
That's 30
yeah, if we could take a look at this base sponge.
Perhaps we'd see something like this yesterday when we were between those two elevated features on the flat top yesterday. I thought maybe the water would be squeezed through there and so keep the sediments off. And in fact, there was more sediment there than we're seeing
A
here.
little, but the
Hey, thank you.
heaving so much.
Yep, that'd be the one. Oh, this is a glass vase sponge. It's a hexactinellid. That's the group. And it's going to be in the family
ROV nav bridge move initiated.
Euplectellidae.
Copy, Bridge.
And now, which one? I think this is something that we call, we think is a member in the genus Dictyalis.
Yeah, we're quite a ways away here. That's
Yeah.
the reason for all the
I think-
bobbing around.
I think we're good, pilot.
Okay.
This is a common one, and you got a good enough shot where we could
Wide
go to a
please, video.
reasonable ID.
There's a coral behind it.
Yeah, there's one over to the right here that's in the nearer distance. Oh, that's well, let's zoom and see what that is, just for ID.
Oh, this
Is
is
that-
another one of those brittle stars that I think we saw earlier. Another Ophiocanthid, but those really long spines. I agree with Tim Shank. This is, I'm pretty sure, a different genus of Ophiocanthid brittle star than the one we've been seeing on corals. The spines alone distinguish this as a separate species. So, and then there below it is a foram test. That's the sediment structure made by a single-celled organism. They're usually deposit feeders, and that it's quite a big structure relative to the fact that it was a single, or at least amoeba-like organism.
Go ahead.
Just a note about who's joined us this morning on the chat room. We've got Asako Matsumoto from the Chiba Institute in Japan. Excuse me. Good morning, Asako. Bruce Mundy from NOAA's Premier Center on Ford Island in Honolulu, the Anoye Regional Center. We've also got James Aubrey, John Smith, and Catherine Weathers. Let's see, Megan Cromwell, Megan McCullough. We've got Scott Franz from the University of Louisiana at Lafayette, and Tim Shank from the Woods Hole Oceanographic Institution.
So, pilot, the DC bus return.
So thank you all for joining
It's
us.
about 1 meg
Uh-huh.
after some more work on CTD last night.
Oh, good.
And yet,
And yet.
we're still seeing that noise whenever we turn the bender on.
Yeah, well, it's probably a pretty high impedance analog input on the
Yes.
A to D, inside the CTD. And, we're talking about a 25 volt spike. 5 polarity
I'm not
spike.
sure whether John is by a phone. John Smith is a geologist with the University of Hawaii Ocean Under Science Technology. He actually has the office next to mine. And John, if you had a chance, we'd love to get your opinion as to whether we're looking at potentially pillow lava formations or whether we're just looking at rounded balls of manganese crusted sediment or something like that. There's a lot of loose stuff around here, and when we see a lot of loose stuff, we start thinking about rocks and how they would fit in a box. But we wouldn't want to collect before we get some guidance from you, because we're still kind of in the flat part of this guyot. So, pilot, there was a little coral stalk to the right. I don't know if that's a possibility.
This guy over
Keep
here.
going. Yeah, this looks different than any of them that we've seen so far today. That one right there.
Yes.
Are,
Starts with a B. Came into my
are you
mind.
referring to that whip, that unbranched thing, Chris?
I sure am.
Zoom, please.
Yeah, I'm really glad you are, so I'm curious to see, this could be the candelabra before it actually gets to the trident branching stage.
Okay, we can go for a big
Well,
zoom here.
We're getting a good look for you, Scott, so maybe you'll be able to
Zoom in.
see from this look.
He's going to be interested down below that where it could possibly branch.
Well, it's a little bit hard to tell, but it very well could be. And one of the things that I am looking at is the relative transparency of the tissue. You can see where the tentacles are just below that. You see inside there's a kind of a pinkish tube. That's the pharynx. And it ends and basically opens up into a space
Pilot?
that would be called the gastrovascular cavity. Basically, it's the stomach.
Hello.
And then the entire polyp gets a little bit wider at the base. And so all of that is consistent with that candelabra, as are those, I only see sclerite needles between the tentacles, and I don't really see them elsewhere. That's also consistent. So this could be one of the trident candelabras at a young stage before it's begun branching. And I really like seeing this because it brings up this problem that if you are a scientist and you're using the video and trying to learn something about biodiversity and species distribution, you really have to understand what these corals look like at different parts of their life, where you can very easily overlook them or overestimate the abundance of one taxon versus another, and so on.
Yeah, well, Scott, I'm glad you're happy to see this. I'm not, given that we have to annotate stuff like this, and this looks like a lot of other things. So it's a very good point that you
Yeah,
made.
it doesn't make your life easy at all. I completely agree. One other interesting thing I'm seeing is it looks like there's a bunch of very
the ship
small
should be coming
polyps,
to stop
maybe
momentarily.
newly budded ones.
Okay,
I think
so you
that's
guys called in one more
as opposed
move.
to just polyps on the
I
other
heard
side.
the word rock.
But this is good. Beautiful imagery, and
Bridge, move
I really
completely.
look forward to studying this later.
Copy,
Another
Bridge.
thing I'll just point out, at the very top there, you notice
Looking
there's
for
no
rocks.
polyp, but it does look like there's kind of a ring of almost like spines. So, it's kind of the leading growth edge of this colony. They do grow from the tip.
Great. Thank you very much, Scott. And I think we're fine for science,
Okay,
pilot.
wide, please, video.
So we're seeing a bunch of bamboos. I'm trying to think, have we seen any other type of coral this morning? I think they've all been in the family Isididae, the bamboo corals.
Yeah, all been bamboo corals. I don't think I remember seeing any others.
I think right now fish are ahead this morning.
Oh yeah, the fish definitely have
Violet
several
video.
chalks up on some of the other groups.
We did pass by a Metallogorgia juvenile colony, but it was so fast while we were following the fish that I don't think you noticed it. But that suggests that we will see others of those, and that has an interesting story with regard to associates, so hopefully we will see some more.
That's good, thank you.
So
Wide, please.
this is one of my animals of interest, since I really enjoy working on glass sponges. I'm certainly no expert on them, but I've learned enough to be dangerous
Pilot
these days.
video.
And this is
Previous.
something that we call Poliopogon. It's sort of a massive it's a family that creates sort of very massive colonies. Some of the species do, at least. That's
Pilot
probably
video.
a young one of these Poliopogon, and
Yeah, go ahead.
it's got, you've heard the story before, it's got a very distinctive way of attaching to the substrate with sort of a grappling hooks. These are modified spicules or microscopic parts. So thank you for that. That was our first member of that group that we were able to log for the day at this site.
Is there something in that rock crevice there? Or is that just a
I
sediment?
see it.
Yeah.
Stand
It's
by.
like a snout or something almost. Oh, it's a
fish.
It's a fish.
It's a fish.
Okay,
It's an
wide, please, video.
it's an ophidiid, I think.
Huh.
Yes, we'll get closer. Full wide, please.
Yeah, you're right. We'll never be able to tell what this is exactly. It's an ophidiiform, I'd have to say, which is the Cuskiel order, because there are two possible families. The clue that we get for that are the thread-like pelvic fins from
Another
under the
fish in the
throat
back.
that we could see in that close-up that we just
there's a
had.
fish
That's
in
a
the darkness up
characteristic
there.
of the Cuskiel or Bracula order.
I think
The
the
two
fish in the
families are
background
the
kinda
Ophidiidae, which is what Chris said, but
very
another
suddenly swam
possibility
away.
is the live-bearing Bracula family, the Thytidae. And this is a very shy little fish, so it's not that little. But, we might be able to tell which family it is from the position of these nostrils. I'll have to look that up, but I think the live-bearing Cuskiels have the nostrils down on the lip, actually. And so this is probably what Chris said, Ophidiidae. I'll have to check on that character, the nostril position. But it's unusual. It's highly unusual to see a fish sheltering under a ledge or a crevice at these depths. Most of them seem to be cruising around. That comes with the caveat, though, that we never know what we're not seeing that's hidden back inside. I can't tell if this has eyes, pronounced eyes or not. It probably does, but we don't see them. It's interesting. We don't see any indication of eyes. So very interesting observation. Different behavior than we see in fishes at these depths. Unlike shallow waters where there's bright sunlight and fish can effectively hide from predators by getting in caves or caverns or under ledges. With the sunless environment here, we usually don't see fish doing this.
So thank you very much, Bruce. And I was noticing the fact that you can't really even see obvious eyes on this thing. Maybe they're further back. They probably are.
Let's come out video wide, please. There's another one in the distance.
There's another fish in the distance?
There, when we came in, but I didn't want to puppy off.
So that actually looks like he was hiding in what appears to be kind of a lava tube or a lava, I don't know what you call dome-like lava structures.
Looks like a
so
like a broken magma vesicle or something.
Yeah, a magma blister or
Yeah.
something like that. I don't know what the terminology is.
Definitely looks like a secure place to be.
Indeed.
Yeah.
Looking for the back door here.
Well, you're gonna those
Oh,
officers.
there's a jellyfish in the upper top in the dark
zoom.
there.
Oh, here's a pretty guy. And away he goes. So hydromedusa of some kind? I think so.
Yeah.
You got a shrimp going by, probably a Canthophyra. Just by it looked like he was sideways.
Okay, this is the fish house.
This is just commenting on that fish. There's a genus that we're familiar with that kind of doesn't swim the way normal things swim. So we could probably go ahead and move on.
There's a little red bit on the center of the screen there.
Red bit. Up, snap zoom.
Oh, good eyes, Chris.
Oh wow, look at that. It's an Anthomastus, a very tiny
but
one.
a very tiny one. 3 polyps only on it.
Little star. Underneath. Okay.
Love the size of that polyp sticking out of that very small face. And it's instructive in the sense that it tells you that polyps, individual polyps, can be full grown even though the colony isn't full grown.
Oh, sorry, I couldn't hear you. You're kind of low. Lasers on.
Yeah, so it's a little dinky thing.
Yeah, he's pretty small, just a few centimeters. Thank you.
Thank you. Oh no, that's the fish. Okay.
What do you mean? Oh yeah, same
no,
one.
I thought I saw something else, but
that's
it's
old
the
news.
same fish. Yeah. There's another fish to the left.
Fish. Where?
Sort of that eolish thing.
Oh,
down
to the
lower.
lower left.
Yeah.
Oh.
Yeah, I might get a head shot on this one here. It's really important to look at the top of the head. Oops, no, he was having none of it.
Yeah, we're close, and the lights are lasers off.
Well, I'll give my same guess as the ones before. It's a halosaur and Eldrovandia, probably Eldrovandia, and Eldrovandia phylacra would be the guess. Little glimpse that I had of the top of the head there, I didn't see signs of scales, so I'm sticking with my guess there.
There he is again.
Thank you, Bruce. There's something sticking up in the background, pilot.
He's hiding in the rock,
left.
right?
I don't know if we're going that way, but after the fish, he's going to give you another chance.
Ooh, is that a sea urchin to the right? Oh, when we're done with the fish, of course.
Yeah, the sea urchin won't move that fast.
You have to maintain the pecking order. So fish trump anything, and then what? Chinoderms and then corals. No, sponges. Sponges are after fish. That's right. No, I guess not. All right.
We're good on the fish. No
Okay.
big deals apparent.
One of these days, there's going to be like a floating sea urchin that attacks fish, and then we'll all be happy. Did you? Oh well. I guess we're past the urchin.
Oh, we missed it. Okay.
They'll probably use rocks to attack the fish with.
Did you even get a glimpse of it? Was that kind of through it, or?
No, it was a sideroid or something.
Oh, sideroid. Okay. Oh, there's something. It's another fish.
Upper.
Oh my
off screen.
goodness.
Left.
I think
Let's
he
see,
shut
yeah.
off. Probably another
Yeah.
halosaur,
Quick
Bruce.
Do people eat halosaurs?
No, I don't think
Moving
so.
towards
I think
me,
I'm
right
gonna
towards
start.
me
No,
here.
no, there's
Staying
no
low.
fishery.
Possible. Yeah.
It's in your manipcam, right there.
No, I don't know about this one. It looks more pale than the ones that we saw before. Maybe like the first one that we saw on the dive.
A lot of fish today, huh?
Yep.
See, why would we want to image things that don't want to be imaged?
Yeah.
Sea urchins love being imaged. They just sit there.
Ah, here we go. There's sponge. Well, we've seen this one before, pilot, so we can.
We worked on that guy.
Yeah.
All right.
Fish keep leading me back the way we came.
Oh, is that right?
Yeah, we were right under Sirius at the moment. Let me push out here and find some new territory.
Sure.
Probably ready for a move then, I think.
Yeah.
Let's get 30 meters going.
010 again?
Here's 015, it's fine. Yeah.
There's something, looks like a shrimp, I guess. Another polyopogon sponge up
30
ahead.
meters, 015 coming up.
We saw
great.
a little while ago.
Go ahead, Nav.
Yeah, these certainly look like little lava mounds, don't they, Chris, to you?
Yeah.
That's range 30
There's something
meters.
weird about them, though. Some of them are
speed
just
doesn't-
outright boulders. So,
Right.
I mean, definitely cemented, but I don't know. Yeah, a lot of them look basaltic.
Yeah, Chris, this is John.
There you are. I knew that there was a geologist lurking somewhere in the background. Hello, John Smith.
ROV Nav Bridge.
I said,
range
hello, John
30
Smith. Tell
meters,
us what we're
0.05
looking
speed
at here.
decimal two initiated.
Well, I've been watching for a while. I thought you guys were fascinated with the fish. So
They are fascinated with the fish. I'm tolerating them.
But now you're going to rock us, right, John?
I don't know. Yeah, it's a little confusing. I think like you guys are talking about the kind of the bigger outcrops, they have a morphology of lava features. But then you've got all these individual hobble-sized small boulders to little pieces that are independent of each other, which is kind of odd that you'd have so much of that. And it's all, of course, coated with manganese, so all the corners get rounded off. They almost look like, a lot of them like beach cobbles, but, that's probably the manganese talking. So it's, they're probably pretty much all the same, those those rocks, but hard to say exactly what you're going to get when you grab one.
Well, John,
John, is it possible that even that we're diving on this cone that's sticking out of a flat overall feature like a geo, and Chris was